Hey, have you ever really stopped to think about what makes things move? You know, what makes a ball fly, or a car stop, or even just a door swing open? Well, it's something that's literally all around us, in everything we do. Today, we're going to dive into this world of pushes and pulls and explore the incredible science of force.
So check this out. It's a moment we've all seen 1,000 times. A powerful kick sends a soccer ball absolutely soaring. It looks pretty simple, right? But believe it or not, there's some seriously cool physics happening in that tiny split second of contact. So what is actually going on here?
Yeah, that's the big question, isn't it? What is that invisible something that can take a ball that's just sitting there and suddenly give it speed and send it off in a new direction? Well, the answer is basically the hero of our entire story today.
And here it is. The answer is force. That's it. It's that simple. Every single time you push a door open, pull a book off a shelf, lift your backpack, or, kick a ball, you are using a force. It's the secret ingredient that causes a change in how something is moving.
And it's true. You can totally think of force as a kind of superpower. It's the hidden engine behind pretty much every movement you can imagine, from a tiny leaf falling from a tree to a massive rocket launching into space. And today, we're going to figure out exactly how this superpower works. Okay, so we know force is a push or a pull, but so what? What can it actually do? What are its effects on the world around us? Let's break down the real superpowers of force one by one.
First up, force gets things going. When a car's just sitting there and you hit the gas, the engine applies a force that gets it moving. And if the car's already rolling, well, a bigger force from the engine will make it speed up. That's what acceleration is all about. It's caused by force.
Now here's the flip side. If a force can start motion, it can also end it. A force can slow down or completely stop something that's moving. Like when a fielder catches a cricket ball, their hands apply a force that pushes back against the ball's motion, bringing it to a dead stop.
But hold on. Force isn't just about starting and stopping. It's also a master of changing direction. I mean, think about a hockey player. They don't just whack the puck to make it go faster. They hit it at just the right angle to pass it or shoot at the goal. That quick push from the hockey stick is a force that totally changes where the puck is headed.
And finally, force can actually change an object's shape. Think about it. Squeezing a sponge, stretching a rubber band, or kneading dough for a pizza. In all of these cases, the force you're applying is physically changing the object's shape or even its size.
So we've seen that forces can start, stop, and steer things. And all our examples so far, kicking a ball, pushing a car, they've all involved things physically touching. But what if I told you that some of the most powerful forces in the universe can work across totally empty space?
This is such an important question. Does something really need to be in direct contact to push or pull on something else? The answer, you might have guessed, is no, and it opens up this whole other amazing category of forces.
This picture just lays it out perfectly. These are the two main families of forces. On the left, you've got a contact force. You literally have to touch the box to push it, right? But on the right, that's a non-contact force. The magnet is pulling those nails toward it without ever touching them. It's like magic, but it's just physics. And the most famous non-contact force of all? You know it. It's gravity. The Earth doesn't need some giant invisible hand to pull a fruit from a tree. Its gravitational pull just works across distance. It's the force that's keeping us all from floating off into space right now. It keeps us grounded, literally.
Okay, so if forces are everywhere and gravity is always pulling on everything, why isn't everything constantly moving and flying all over the place? Why does a book just sit on a table? This leads us to one of the most important ideas in all of physics: balancing forces. So, let's look at this car. It's not moving. It's just stationary. Pretty simple, right? But let's think a little deeper here.
No way! Absolutely not. This is key. Just because something isn't moving doesn't mean there are no forces acting on it. In fact, it usually means there are multiple forces at play, all working against each other in a kind of perfect standoff.
And here it is, the big secret. When forces are balanced, it means they're equal in strength but pushing or pulling in opposite directions. So they just cancel each other out, and nothing changes. But the moment one force becomes stronger than the other, they become unbalanced. And that is when things really start to move. Let's go back to our car. Imagine someone is pushing on it,
but the force of their push is exactly equal to the force of friction from the ground pushing back. See the arrows? They're the same size. The forces are perfectly balanced. The result? The car doesn't budge. To get it moving, that push has to become an unbalanced force. It has to be stronger than the friction.
All right, so now we get what forces are and what they do, but how do we actually talk about them? How do we measure how strong they are? To do that, we need to learn a little bit of the language of physics, and it all starts with one very important name, Newton.
You know how we measure length in meters, or time in seconds? Well, we measure the strength, or as physicists say, the magnitude of a force in newtons. We write it with a capital N, and yep, it's named after the legend himself, Sir Isaac Newton, who basically wrote the rule book for motion.
So what does 1 Newton even feel like? It sounds so abstract, but here's a super easy way to get a feel for it. The force of gravity pulling down on a small apple, something with a mass of about 100 grams, is roughly 1 Newton. So next time you're holding an apple, just think, you're feeling 1 Newton of force right in your hand.
And this brings us to something that trips a lot of people up, the difference between mass and weight. They sound similar, but in physics, they're totally different. Mass is how much stuff is in an object. It's measured in kilograms, and it never changes no matter where you go in the universe. Weight, though, is a force. It's the force of gravity pulling on that mass, and it's measured in newtons. So your mass is the same here on Earth as it is on the moon, but you would weigh a lot less on the moon because the moon's gravity is much weaker. See the difference?
Okay, so I've got a mission for you. As you go about the rest of your day, I want you to become a force spotter. It's easy. Step 1, look for any push or pull happening around you. Step 2, see what effect it's having. Does something start moving, stop, or change shape? And finally, step 3, ask the big question. Are the forces I'm seeing balanced or unbalanced?
Because that's really the main takeaway here. Force isn't just some word in a science book. It's the hidden script that's directing every single movement in the universe. Now that you know the secret, you can start to see it in action everywhere. So think about it. What invisible forces are shaping your world right this very second?